Hey, 11th graders. So we are moving on with our chi-squared tests. Last class, we learned about chi-squared test for goodness of fit. And now we're learning a different test that's still under the category of being a chi-squared test. We are now learning about the chi-squared test for independence. The main idea with this test is, are these two variables independent of each other? Whereas on our previous test, it was we expect for our sample to follow a specific distribution. And then we're saying, okay, did it actually hit that distribution? Now our test for independence is saying, okay, we've got this one idea, this one variable, and this other idea, this other variable. And we're saying, okay, are they influencing each other at all? And so just visually looking at the tables that we get for chi-squared goodness of fit, as opposed to chi-squared test for independence, you'll see that there's just a visual difference on the way that the tables are brought out. This is from your 9.2 goodness of fit test. You'll see that we just talk about one variable on goodness of fit. In this case, it was language, and then you were given frequency of that language, right? But still we're just talking about language, right? And here we were just talking about time and then frequency of that. Here we're talking about cashier and frequency of cashier. Those are all just one variable at the table. Here in the table, you can see, okay, we've got genders here and then type of music here. So automatically, visually, you can see that there are two different ideas being compared here. And that's your number one clue that this is going to be a test for independence, is that visually the table that you're given will look like it's a test for independence. You should be able to spot it super quickly once you know what you're looking for. So the main idea is, okay, are these variables influencing each other at all, right? In this case, they're trying to figure out, is gender influencing the type of music that you have a preference for, right? So we're trying to see if there's any type of relationship between these two different variables. Our null hypothesis is always going to be that those two variables are independent. We have a lot to write in this space, so just a heads up, I would write a little bit small. And of course, we're being very generic with these hypotheses that we're writing up here as help for future me to be able to digest what's going on with each type of test. But make sure that you are specific. You shouldn't say the two variables are independent. You should say gender and music preference are independent. You should be specific about what are we talking about as independent. The alternative is then that they are not independent. Okay. A few things to keep in mind that you might be asked around this that has formulas or something around it. Remember that we talked about degrees of freedom, the amount of variability that our tests have. How many options are there? This one is slightly different, although it'll feel familiar from our previous degrees of freedom. Remember, degrees of freedom last time was n minus 1, and now we're just taking that and multiplying it by m minus 1, where n is the number of columns, and m is the number of rows. So we're taking our two different amount of options and then subtracting one from each of those amounts of options and then multiplying it together. Make sure that you do not include the totals as an option, right? So not the totals, just the number of options, right? So the number of options for music is 4. So 4 minus 1 would be 3. And then the number of genders available are 3. 3 minus 1 is 2. So you do 3 times 2 to make 6 for the degrees of freedom. So slightly different, but kind of familiar. Expected frequencies. is something else that you're asked to calculate. There's a formula, although I don't think the formula is super helpful to know, but you might just kind of see it floating around as you look at other material, or you might like look on Revision Village. Not super helpful because it's not on the formula packet. And there's a way that you can kind of like figure it out if you understand the concept of it. But here's the formula where R is the row total, C is the column total, and then N is just your absolute total. Again, I'll go into detail of what this means later on, but if you just write that down here. I'm also going to write down the calculator steps for TI Inspire. Obviously, TI 84, you'll have on the resources page a video available to you if you want to pull that out and watch that video real quick when we do our first test. But here are the calculator steps, and I encourage TI 84s. Calculator. I encourage TI 84s to also write down the steps here once you know them. Just go ahead and write down the steps, and then we'll talk about it later. So the first thing you have to do is make a matrix. The matrix that you make will only be the observed values. So we only get observed values, which is why expected values are something that you might have to calculate for. It makes sense that if you're going to go in and you're going to into a population and you're going to write down like, okay, who falls into what category? Are you identifying as male who likes pop, female who likes folk, right? So you're just going in and saying, okay, this is where everybody kind of goes into. So obviously it's all observed. You would then have to go in and calculate expected later. So just keep that in mind that the only matrix that you make is the observed, and it will always be given to you. Here are the steps: menu, 7 matrix, 1 create, 1 matrix. Once you make the matrix, you then have to store the matrix. How you do that is you press the control button and then vars, which notice above vars, it says STO, which is short for store. And then you give it a label, any label. You could label it just A. I always label it OBS, which is short for observed, just because it's what I do. I don't know, but you could do O for observed, or you could do A, or you could do M for Megan. It doesn't matter, but you do have to give it a name. We'll see how this looks when we run the test in our next examples. The last thing is then we actually run the test, which happens menu 6, which is statistics, 7, which is statistic tests, and then 8, which is labeled as the chi-squared two-way test. Two-way because we're talking about 2 variables, right? So this is the only hypothesis test that will not be using a spreadsheet, right? So in our last test, we used a spreadsheet in order to put in all of our data. Our last tests will also be using the spreadsheet to put in the data. This does not use a spreadsheet. We have to make a matrix, essentially, in order to put together the information, the numbers that we've been given. Okay, so these are all the things that are going to be super important for you to have with you to understand how to run each test. This is like your little like cheat card for each test at the top. So hopefully you have all of this written down. If not, pause the video now and get it down there. Okay, so example 1, let's go ahead and figure out what it's about. So it says 80 people were asked for their favorite genre of music: pop, classical, folk, or jazz. The results are in the following table. So what they were actually testing for is, hey, does gender identification have any influence on your type of music that you prefer? It says a chi-squared test was carried out at the 1% significance level. The critical value for the test is this. So it does not specify which type of chi-squared test. So it's up to you to know what type of test it should be. And we know it's going to be a test for independence because we're trying to see whether there's an influence or not of one variable over the other. And you can also see visually that we've got 2 variables being compared to each other: a variable up top, which is music, and a variable on the side, which is gender. So when it says write down the null and alternative hypothesis, you have to first say, okay, what test am I in? I'm in test for independence. So then what hypothesis goes with that type of test? Well, our null hypothesis for test for independence is always that they are independent. We'll be specific though. We'll say gender and music preference independent. And the alternative is, of course, that they are not.